Welcome back. It might seem like a mess laid out on the table, but it's actually going to be pretty cool. Today we're going to be upgrading this rig behind me from lead acid to lithium iron phosphate, and we're going to be upgrading the capacity to be about 8 times the capacity it had before, and it's all going to go in this compartment right here, and we're going to show you every step of the way. Now, to get this video going straight to the point, I'm not going to explain everything here on the table. We're going to have links to where you can buy everything down in the description, and we'll list everything out down there. Let's get on with the video. So first things first, these are the old lead acid battery, and you can see the connections up here are a bit of a mess, but that's okay. We're going to be cleaning that up. Now, a prerequisite before you order anything is you want to know how big of a battery management system. Now, the biggest load we have is the cranking current required for the generator. So I'm going to use my Klein Tools clamp meter here, and I'm going to set it to amps in DC mode and zero it out, okay? And then I'm going to change my range on this to be 10th volt range, otherwise this will go overload. And then I'm going to put it in min-max mode, and I'm going to clamp it in here around the leads that go to the generator, and we're going to go ahead and crank the generator and see what the surge current is. Go ahead. So as you can see right there, that little crank got us a 203 amp draw. We're going to try a couple times just to see the maximum draw of this generator, and we're not trying to start it, we're just trying to see what the maximum draw is. So it looks like the most we got here was 246.1 amps, and that is great information. It's not all that large, and we're going to be able to handle that kind of current with our new batteries and BMS. So let's check that out. So speaking of the BMS, this is the one we're going to be using. This is a 200 amp, and I know it says Deli Green, but this is a Dali BMS inside, rebranded by Deli Green. I like these ones because Deli Green is really nice to work with, and when you ask for this type of BMS, you get this type of BMS, not a surprise. So many people have had issues with Dali BMS, communicating with them and getting exactly what they want. So anyway, like I said, link for this will be in the description below, and we have the BMS and a bag of accessories. Now, I know we measured 240 amps draw for that generator, but this BMS is rated for a 200 amp continuous draw, but we're allowed to have surges on this BMS up to 300 amps, and I've tested this type of BMS before, and I've had no problem drawing over 400 amps through a 200 amp BMS for a brief period of time. So that's the BMS we're going to be using, and let's move on. In order to make room for our new batteries, we're going to have to pull out these old lead acid batteries. Now, these batteries haven't gone completely bad, but they've sat dead a few times, and it's time to get rid of them and go for the much more powerful lithium iron phosphate. These are held in with just a ratchet strap. It's kind of hokey, but it's what the previous owner of this rig did, and I guess it works. And it's going to be a little bit of a challenge getting all this on film, but we have our main negative terminal here and our main positive terminal in here, and we're going to need to do a little bit of work to extend these to make them work with the new system. But I'm going to go ahead and disconnect the main negative first, and you always disconnect negative first because then the frame is no longer live, and when you start working on the positive terminals, if you short out to the frame, it's okay because there's no circuit through to the main negative terminal of the battery, and it's safe. Now, it probably would be better to use a ratchet and wrench, but the old crescent wrench has never let me down. All right, was a little bit of mess in here of wires, but that's okay. We're going to correct them all. If you're not sure which wires go to what, it would not hurt to put some tape on them or something to mark which wire goes to what. But these, for the most part, are color coordinated. Like this one goes to the jacks here. I've got a black and a red. That's fine. I've got a white wire here that goes to the frame. That's fine. red wire here that goes to the RV, that's fine. Some accessory wires here, black and white wire. In this case, this is the positive, this is the negative, so that's fine. And then this is the positive terminal going to the generator, so that's fine as well. So we're good to go, and we just need to get some plywood that I have right here. I'm going to cut this for this footprint of this compartment. That way the new batteries have a really nice platform to sit on and they can all be true to each other. There's a structural member right here that runs across, and I can just screw that piece of wood in there and it'll make a nice area. And then if we want to strap the batteries towards the back wall, it'll work perfect for that too. We can get some sort of D-ring or something on there, and we can really make sure these batteries are secured, so as this rig goes down the road, nothing bounces around. So I've got the wood all screwed in. Now we're ready to start playing with batteries. Okay, so let's take a second and talk about these batteries, because I feel like I might lose you if I don't pause right here. So each of these cells is a 3 volt, 170 amp hour cell. Like I said, link for these is in the description. Great place to get them. So anyway, let's say this is 3 volts and 170 amp hours, okay? That doesn't do us much good. We need 12 volts. So the way we get 12 volts is we connect cells in series. So for example, right here, if I took these two cells and I put a bus bar from the positive of one cell to the negative of the next cell, now this is a 6 volt battery, and you would have the main negative terminal here and main positive terminal here. And that's great if we only wanted a 6 volt 170 amp hour battery. But let's say we wanted a 340 amp hour battery so that we have more capacity to run our rig for more days when we go camping. Then you would need a parallel connection to increase capacity. So if I spin this cell around and I connect both positives together and both negatives together, now we've created a 3 volt 340 amp hour group of 2 cells. So our main negative would be here and main positive would be here. Typically you would want to connect them across from each other, one side or another. And let's say we wanted to increase that capacity further. Let's say we wanted another 170 amp hours. We would add one more cell and put more bus bars, and it just adds up. So we would have 170 times 3 amp hours. But this is still only a 3 volt block. So it still isn't of use in our rig where we need 12 volts. Now one thing I want to mention, I put this bus bar on here a little crooked. You would never want to bolt these two together. You would need a spacer here to make them all flat with each other. So just a heads up, if you're trying to do this type of system, that could be something you want to make sure of when you're buying your bus bars, is that you're planning for them all to be on the same level. So let's say we want to build a 12 volt 510 amp hour battery. We just take this block of 3 and meet it up with 4 more, and we're going to configure the bus bars in order to make this a 12 volt 510 amp hour battery. So I'm going to start by putting in this bus bar, which just paralleled these 2 cells, and this bus bar, which actually seriesed this block with this block, and I'm missing one here. So now I have this block in parallel, and I'm just going to add a couple more bars and you'll see it all makes sense. So now I've kind of mocked up these bars. So this group of 3 batteries is going to be cell 1. This group of 3 batteries will be cell 2. This group of 3 batteries will be cell 3. And this group of batteries will be cell 4. Now I've applied labels to all these cells that call them cell 1A, 1B, 1C, cell 2A, 2B, and 2C. And we're going to come back to this later, but you can see how we've now paralleled and series these cells up in order to create a system that can have that 510 amp hours at 12 volts. So now that we know how this is going to be built, I'm actually going to be using some 3M VHB tape to be sticking these together. We'll show you that now. So now I've got these batteries roughly placed in here, and I've made sure they're going to fit. So now it's okay to stick these together with the VHB tape. Now this stuff is pretty permanent, so you want to make sure that everything's going to work out exactly how you want it before you put this on, because once it's stuck, it's pretty well stuck. Now a tip I want to share with you guys, this is the tape right here, this gray part, and you can see I have the red part still attached. When you're putting this stuff on, you want to start by pulling off the gray part and keep this separate. If you cut through this, it's a real nightmare to try and separate this protective tape from the actual adhesive itself, because this stuff is so sticky and so strong. It's just a nightmare to try and get this stuff off. You almost need tweezers at that point. So if you keep it peeling off as you go, it'll be much easier for you. So I'm going to grab these cells and show you how I do this. Now it's not optimal that I'm doing this in my lap, but for video's sake, it's going to be the easiest to demonstrate. So I'm going to apply a strip like this between the cells, and it's also going to help to have this little bit of space between the cells because it'll allow some airflow, and the tape is going to prevent any vibration from rubbing through the plastic sheathing on this cell. So I can go ahead and get that in there and cut it, and that's one strip. Now you don't want to do what I just did with dirty fingers because you'll cause the adhesive to not hold as strong. So now I've got another strip in here, and I can start it like that and go ahead and cut it. And now this is ready to stick to the next cell like this, and I'm going to set it on there so they're nice and flat and then squeeze them together. Now I've only joined together these two cells, but I'm going to repeat this process going through all of the cells, and then at the very end I'm considering putting some strips of VHB tape between them, and then to put the icing on the cake I'm going to use some large zip ties to hold the entire pack together. Alright, so these are now all stuck together. I can't separate them, and it's nice because I can actually move them as blocks. Now, I have a little bit of a challenging design here to decide on. I can either put these batteries just like this, and this is great because if I want to add another parallel connected cell in the future to make this now, I think it's 680 amp hours, I could just add one on this side, well, two, I guess I should say, to each group, and then two on this side, and then we'd have 6 batteries that would be, like I said, 680 amp hours at 12 volts. But it's a tough call because these batteries also fit really nice. If I put them in here like this, and I have some wires stuck back there so they're not perfectly in line, but this makes the bus bar situation a little bit easier. But if I stick these together with VHB tape here, it's not very easy to separate that. Although I will give you one tip. If you do need to separate VHB tape, you can use fishing line and kind of saw through it to separate it. But anyway, my other thought is if I ever wanted to upgrade this, I could add another 12 batteries in the front and make it into a 24 volt system. So I'm kind of on the fence, but I think the best solution for now is going to be to stick with my original plan and slide these over here and put them like this, because then I may shift this over too, by the way, but then I can put my zip ties around it, ratchet it into place, and if I don't stick these together in the middle very good, I still have the option to pull them apart and go back to the other configuration. So that's what I'm going to do, actually. I'm going to go with this. So let me get the bus bars going, and I want to show you how we make the bus bar that goes in the middle that doesn't quite fit. Let's check that out. On this pack, I have already decided my main negative terminal is going to be right here. So that being said, I'm going to go ahead and start getting these bus bars into place. So what I'm essentially doing is starting with negative here, positive here, and that's the first cell. Negative here, positive here, that's the second cell. Negative here, positive here, that's the third cell. Negative here and positive here, and that's the fourth cell. And you can follow along with the labels if you can see that closely. So if I connect them just like this, kind of like we showed earlier, that is going to work out pretty well on every connection except for the main terminals and over here where I need to jump between the two banks. And I'll show you that here as I go. Oops. So with all of these bus bars in place, I need to figure out a bus bar that'll go between these two. Now, these bus bars, if we take a close-up look, I have these designed with slots in each side, so there's quite a bit of variation in them. So this slot, by the way, is 7/16 from outside to outside. So what I'm going to do is I'm going to kind of put it on this stud on the outside of the slot and drag it over the top of this other stud, and then I'm going to slide it over to the inside of the slot and drag it. And what I've done is I've made scratch marks for where this is going to meet up. Now all I need to do is get a drill bit and drill a hole in there, and that hole will allow this to set down on top of this these batteries, and I'll still have a slot on one side so there's flexibility, and then I can put the bus bars across here and across here. So I started out with a 1/8 hole, and now I'm going up to 5/16. Now, if you have any big burrs on here, you're going to want to remove those before proceeding with the next step. So now you can see this bus bar fits perfectly in here, and I can go ahead and put in my other two bus bars, and now these are connected in series, and almost all of our connections are done. The only thing I'm missing is I need a connection out of here, but if I were to put a bus bar like this, you can see there would be a gap down here, and it wouldn't be good to just tighten this down because it would cause stress on the terminals. So what I'm actually going to do is when I bolt all this in, I'm going to put a bus bar like this. And if you need an extra bus bar, there'll be a link in the description to get the bus bars individually. But then I can bolt a ring terminal through this bus bar and come off the battery pack like that. And I'm thinking I'm going to put a little bit of heat shrink over this bus bar as well to protect it from having any risk of shorting out. So now I'm going to go ahead and start preparing the nuts that hold the bus bars down. Now I still need to get balance leads for a BMS on this, so I'm leaving off some of them, and it's going to be one nut is left off of each cell's positive terminal. That way I can get a balance lead on each cell's positive terminal for the BMS. And we'll show you all this stuff. Let's get the nuts on first. Now you may be wondering why I didn't use any washers or lock washers. That's because these nuts are serrated nuts, and as you tighten these down, they're going to bite into the aluminum bus bars, and they're set up in such a way that in order for them to back off, they actually cut into the bus bar, which you can imagine isn't as easy as just when you tighten them down. So no lock washers or flat washers necessary. These serrated nuts have got you taken care of. Now I'm going to start getting the BMS ready to go. Now this BMS link again is in the description below. These are the accessories it comes with when you buy through the link. However, you may not get all of these every time if you buy from a different source. But anyway, in this bag, we have quite a few different things. First things first, there is a button here. And this is a button to activate the BMS. So here on the side of the BMS, there's a 2-pin connector right next to the monitor port that this plugs into. And then when it's all hooked up and you push the button, it'll turn on the BMS. There is a Bluetooth dongle option that I went ahead and got here, and that plugs over here into the UART port, and you can imagine that just goes in there like that. I'm not going to hook that up quite yet. I'll do that later. And then most importantly, there's a probe here. This is a low temperature sensor. That goes into the NTC port right here, kind of like that. Now, if you don't have this probe plugged in, the BMS won't turn on at all. It's absolutely required for this to turn on. Otherwise, it thinks it's like negative 200 degrees Celsius and won't turn on. And then there is a USB cable included. And this you can plug into your computer and program all of the parameters in the BMS. And then I intentionally put this last. This is the balance harness. So this plugs here into the side of the BMS once it's all connected up. And this is how the BMS monitors the voltage of every cell and makes sure that nothing's getting undercharged or I should say over discharged or overcharged. So we need to connect this up to every single cell. And it's a 5-pin header. We have a black wire and 4 red wires. The black wire is going to go onto the main negative terminal. But in order to do this, we're going to utilize a ring terminal. And I'm going to get this stripped back some more and crimped on. And then that'll just go on the negative terminal of the first cell. You can see I labeled these cell 1. So this block is now cell 1. So this will go on cell 1 negative with a ring terminal. And then the second pin on this harness will go on cell 1 positive. The second red wire will go on cell 2 positive, which is this screw right here that I didn't put on. And then we're just going to keep continuing on. So the third red wire will go onto the third cell positive here. And then the fourth red wire will go onto the fourth cell positive over here. And it's pretty easy. And if you want to make the wiring neater, it is perfectly okay to cut this harness shorter. Or if you need extra length, I have some number 16 wire. It doesn't have to be number 16. This harness here is like number 22 wire. But I'm just going to use, if I need to extend it, some crimp-on connectors and just make it longer. It's not carrying any real current, so it is totally okay to change the length of it. So like I said, we're going to get this going. We're going to get ring terminals put on each of the leads. And these have heat shrink, so I'll go ahead and shrink those as well. And then we'll get to hooking up the BMS main power cables after that. To make things a bit easier, I'm taking out the screws on these main power leads, and I'm actually going to flip these around so they go out the other side. It's just going to make getting the balance harness connected a lot easier. And this is totally fine too. It's nice and easy to take out 4 screws, and then this just comes off and we'll connect on like that. And now my main power leads are on the same size or side as the balance leads. So when I put this in here, I can have this up on top with the wires coming out the top and easily connect the balance harness to each individual cell like we talked about a moment ago. I gotta admit, I like using VHB tape for just about everything. So it shouldn't be a surprise that for mounting this BMS, I'm using VHB tape. I'm just putting it on the back of these little black tabs, and instead of screwing in the BMS, I'm just gonna stick it to the side of the batteries. And it'll be just fine because even though this BMS looks like it's all supposed to be a heat sink, it actually doesn't get very hot unless you're sustaining really heavy loads for a long time. And they make, for like larger BMSs, they make this in a 300 amp BMS that has a fan on it. But even those under heavy loads, the fans don't run very long. So sticking this in place, I'm thinking we go right about there. And my reasoning behind that, I need a bus bar right in here. And I'm going to use a 5/16 bolt to attach this negative terminal here. So I'm thinking I'm going to take the negative of the BMS and put it in right here with the nut. And then I have a good setup right here for putting the bus bar in. They're both at the same level. And then I can get some heat shrink around this. And I'll probably go find a shorter bolt for this. And then I have a big old piece. This is 1.25 inch glue lined heat shrink. And I think I'm going to just go ahead and put that over there. And that'll reach onto the battery terminal just fine. And I'll actually put it like that with the the bolt head, the long part sticking up. We do have enough clearance in here, so we'll just shrink this down and that'll be just fine. Look at that, the glue even seeped out of the end a little bit. That came out real nice. And yeah, a shorter bolt would have been nice, but I didn't have one handy. So now that can go there, and we can put our other bus bar on here. And all I need is a balance lead, but we're just about ready to get that harness made up and put everything on. I like that. That worked out pretty well. Definitely worth using the extra bus bar. And then now this is our main negative terminal. All of our loads and stuff will go onto that. And this right here is our main positive terminal. So we're going to have to do similar with a nut and bolt on that for all the positive leads. But first things first, let's get in our balance harness. So I'm figuring out the lengths for my balance leads. I'm just kind of bending a kink on them where they need to go. So the negative, main negative will go there. Cell 1 positive will go around over here. I'm trying to figure out how it's going to be routed. So I'll cut it and crimp it there. And then cell 2 positive, it looks like it's long enough, so I'll go about there. And that's where I'll cut it, right at that kink. And then cell 3 positive will come kind of around and over here. So I'll go about like that, and that'll work out. And then in the end, I'll secure all this with zip ties. And then I'll kind of follow the other wires through here and go to that terminal there. Now, the cell 4 positive, I should in theory be putting on this post, but since there'll be a bus bar between them, it's not as critical. I don't want to get involved with all the connections that will be on that post already, so I opted to scoot it over a cell, and that's where I'm going to be crimping it there. Now that I've got all those lengths, I can unplug this harness, and this right here is the WireFi kit I've used on the channel before. I love this kit. This is the best crimping tool I've ever used, and it comes with some real nice strippers. So I'm going to use the 20 gauge setting on these and strip these pretty long. But the reason I stripped them pretty long is because I'm going to give them a twist and then fold them in half before I insert them into these connectors. Now, this wire is a little small for these connectors, but my choices are somewhat limited. And once it's in there like that, I'm going to use the set of dies in this kit, which come out just really easy. I'm going to use the dies for heat shrink terminals. And with those installed, now we just go ahead and crimp these like normal. And the best part about these ratcheting crimpers is once you've squeezed it, it's fully compressed down. You're good to go. You just need to shrink this with the heat gun, just like the tubing we just did. And there you have it. Now the heat shrink is holding onto the wire, so we know it's not going to pull out. And we also crimped it right, so we're 100% certain that we won't have any issues. So I'm just going to do this on the other leads of the harness, and we'll get it hooked up to the batteries. All those ring terminals are in, so now we're kind of at the point where we can start tightening down all the nuts. So that being said, don't need to tighten anything in a specific order. Just be careful when you're doing these balance leads, because the nuts like to grab onto them and twist them. So you kind of need to bring them back a little bit farther. And then as you tighten it, they'll go back into place. And don't plug this in until everything is tightened up. It's not good for the BMSs to only see 1 or 2 cells at a time. And if you need to change these balance leads in any way, unplug it from the BMS, and that'll make sure everything stays safe in terms of the BMS. So we'll tighten everything up. All right, everything's in. Now it's time to get some zip ties. These are monster zip ties. These are like, I think 36 inches long, and it's going to take 2 of them to go around this whole battery. Luckily I have plenty, but these are just to keep things from moving because I didn't put any VHB tape in the middle. Even if you did put VHB tape between cells, some level of compression on these cells is actually good in terms of keeping them all together, because they do tend to swell a little bit during normal charging and discharging. But having a little bit of compression from these zip ties, like I said, is good for them. Not totally required, but it does help. Especially if you're doing low C rate, it's not critical. If you do high C rate, like these are rated for 170 amps per cell, you definitely want a good jig with maybe some threaded rod to compress the cells. But for our example, let's say we have this BMS maxed out at 200 amps. That's only going to be about 60 amps per cell, a little over that, about 66 amps. And that's a pretty low C rate for these. So just using the zip ties for compression is perfectly fine. There you have it. There's our zip ties. And now if I just grab some side cutters, I can trim these off. And they're not super crazy tight, but that's okay. If I need to tighten them, I can always just push a little bit through later on. And now this is ready to kind of move into place, and we can start focusing on our electrical connections. Back here, I'm trying to get the P-, which is the negative output of the BMS, all good to go. As an example, you see this monster ring terminal? This would not be good on here. And it was like that on the old batteries that had a similar stud size. So this is the negative for that same device. I'm going to crimp on instead the proper size ring, and that'll just go on here like that. And ideally, I'd be using a 4-stud bus bar, but hindsight is always going to get you. I don't have that right now, so for now, I've slid on a piece of that heat shrink tubing. I'm just going to shrink it down for now, and if I decide to cut it off later and put a bus bar when we add something, maybe we add an inverter or something like that, I'll put the bus bar in at that point. But for now, I'm going to get this ring crimped onto this other negative cable, and I'm still going to be using the ratcheting crimper that I used earlier. Nothing super fancy, but I put the insulated terminal dies in. These are awesome because it also crimps the back side of the terminal to get a better bite on the wire. So this tool is definitely the way to go. If you don't have them already, click on the link in the description and get one. And you know it's crimped right because it puts a little indent stamp in there, and this is definitely not going anywhere. So back here on this other bus bar, I went ahead and connected all the positive leads. Not the best thing in the world. I mean, I can show you under the heat shrink. There's just a bolt with all the connections. And then I'm just going to slide this heat shrink back over, and that'll be good enough. It's not the best. If I could get this revised onto a bus bar, it'll be much better. So I'll get one of those ordered. I'm not going to shrink this down quite yet, but I do have it over top of all that in order to keep it protected, so that nothing can short out and, you know, it's all safe. And obviously we have exposed terminals on the top of this battery, which is not optimal, but there's supposed to be nothing else in this compartment, so I think we'll be safe as long as nobody goes throwing a wrench on here. So we're just about ready. I'm going to plug in the balance harness into the BMS. And we're obviously missing a step here. We need the NTC probe, which sometimes is a little tricky. It may take a small screwdriver to push it in all the way. Once I plug this in, it has everything it needs, but it's not ready to turn on. Now, by the way, you can just use some VHB tape or something, and this NTC probe is just here to check the temperature of the batteries. I'm actually just going to shove it in here on this zip tie. That's plenty good enough. It doesn't have to be anywhere specific. But anyway, so to activate this BMS, there's a couple different ways to do it. Obviously, the easiest is going to be just to push the button. But if you don't have this button, if you pass charge current through the BMS, that will wake it up. Now, some chargers won't turn on unless they see the battery. So you may have to jump across the BMS so that the charger can see battery voltage. And then once the charger turns off, remove that jumper, and the charge current will be rediverted through the BMS and wake it up. But in our case, we have this nice easy button. When we press it, we see on the multimeter 13.1 volts. That means this pack is good to go. I actually just heard the fridge kick in, and yeah, this is up and running. Now all we have to do is get a little bit of security on this to make sure it's not going to come anywhere, like move out of the RV or anything. And one thing I also want to show you, if I move this probe to the pack negative terminal, I have 0 volt difference. This is normal. If you have any difference in voltage here, it's likely because the BMS is not activated. And if you're overcharging this battery pack, the BMS will stop the charge current, and that may be another reason why you have a difference in voltage. Now, those of you curious, I'm going to check all of these cells. Obviously, these are not the best probe. 3.28 volts on block 1, 3.278 volts on block 2, 3.28 volts on block 3, and 3.279 volts on block 4. So these cells are really close together, and that's typical with this, this specific battery. So sometimes top balancing manually is necessary, but I've found that these batteries are usually so close together from the factory that a manual top balancing procedure is not necessary. And if you're a beginner, don't even worry about what all that means, because this BMS is able to balance out these cells. So if there's a little bit of difference in voltage, you may not reach full capacity at first, but after they cycle for about a month or so, everything should be totally in balance and good to go. Now, if you're using used cells, maybe a different story, but for these brand new cells, they're also closely matched that this is turnkey and ready to go. So let's focus on getting these secured in here a little bit better. So in order to secure this, I'm going to kind of copy what the previous person did. I've got two electrical 3/4 inch 2-hole straps for EMT, and I'm just going to screw this in back here because this battery bank is going to shift down, and I'll put one on the other side, and I'll just put the ratchet strap around here, and that should be totally good to hold this in place. It's not like the cells are moving, and if we hit a big enough bump for this thing to come up in the air at all, I've got bigger concerns about the rest of the rig. So we're just going to throw a strap in here and hit it in that same structural member we attached the wood to. Now I realize I'm going to have to put the hook pretty far over on this. Otherwise, this the metal part of this strap will start digging into these batteries, and I can't have that. That'd be no good. So it'd be nice if this was a little shorter, actually. So this other side will be a little bit interesting. I'm going to do some, not my proudest work, but it'll be okay. I'm going to put some heat shrink around this strap because these are a little bit sharp and I don't want that. So I'm going to get my heat gun and shrink this down. So the reason I put heat shrink on that one is because on this side, I had to get a little creative. If I would have just hooked this on here, I'd have this metal strap digging into the batteries, and that's no good. So what I'm actually going to do is hook this onto itself over here. So that way this is a little bit shorter, and I can put that through there. And now with that heat shrink, it's not going to cut through. When I put my other screw, I'll be able to secure this without putting the batteries in harm's way. And there we go. That is nice and secure. I couldn't move that even if I tried, so I'm sure that bouncing down the road, this will have no problem at all. If I really wanted to, I could put a strap over top of it, but I think that's overkill. And I made sure I got one full wrap around this before I tightened it. And the next guy is going to hate me, but I'm going to cut this short because the next guy probably won't be here changing batteries. It'll probably be me, but the next guy won't be here changing batteries for probably as long as we own this rig, unless we're expanding them a little bit bigger. But anyway, this is in and good to go. I have the Bluetooth module connected into the BMS, and I have the USB cable. I'm thinking I'm going to zip tie this kind of out of the way over here. Let's see if the BMS can handle cranking over this Generac. Now this is like a, I think 5,000 watt generator. Maybe bigger. This is pretty old, but it's propane, and let's give it a go.